Okay, so listen up. We already talked about vertex form a lot. You guys have been working with this pretty much the whole entire chapter so far. But there are two other forms. We have standard form and we have intercept form. So when we have standard form, intercept form, and vertex form, there's always one thing that you can absolutely find, and then it's very unique to that form. So standard form. The one thing that you can find that's unique to standard form is called the y-intercept. Okay, so when you're given something like that standard form, this C value right here is going to tell you your y-intercept. Yes. Yeah, highlight. Highlight works. Okay, now your y-intercept. What is x when you have a y-intercept on a graph? What would x be? Yeah, what would it be? What would be the value of x? What would be the number for x if we have a y-intercept? Like if I cross right here, what would be my x? 0, thank you. Okay, so 0 comma c. So again, it's just the form. So when you're looking at standard form, right away, the number all the way at the end, or just the number, is going to tell you what your y-intercept is. Okay, then we have concavity, which we've been working with, and then we have end behavior, and that goes for all three of them. But the one unique thing about standard form is the y-intercept. Okay, so then we have concavity, which is just concave up or down. You should know that one pretty easily. Okay, and then we also have end behavior, which you've never learned before, at least if you were in this class the whole time, or if you were in instructional math 2 last year. Okay, we're doing end behaviors. It's going to be more important when we get to the next couple chapters, but it's pretty easy when it comes to quadratics. Okay, so let's do an example. So we're in standard form. We know that because there's three things going on. There's an x squared, an x, and just a number. Okay, so do you guys know what the concavity is? Is it concave up or down? Down. And we know this, I'll draw an arrow for those that did not know, is because that negative all the way out in front. Have a good one. Wait. Watch the video. Yep. Okay, your y-intercept we just talked about. It's that number all the way out at the end. And draw an arrow there so that you remember where it came from. And that's going to be at 0, 7. So just by knowing standard form and the things that you can figure out from it, like y-intercept and concavity, you can kind of visualize what your graph's going to look like. Okay, so we know it's concave down, and we know we have a y-intercept at 0, 7. I'm going to draw this out. You do not have to do this every single time for your homework, but I just want you, for this part, the end behavior, I want to make sure that you understand what I'm doing. Okay, so your y-intercept's going to be at like around 7 up there, and it's going to be down. So I don't really care how you draw it, but it's going to be going down. And just for this one, I'm going to draw it out. I'm going to put in my negative infinity, my positive, negative, and positive. I told you guys I like doing that for domain and range, but it's super nice to visualize when you're talking about end behavior. Now, end behavior just means your ends. Where are your arrows going? They're both going down, but I'm going to explain to you visually, so I don't want you to write right now. I just want you to watch visually. Okay, as x is getting smaller, that's what this means, the limit. As x is getting smaller or going towards negative, here it goes. I'm going towards negative. Where is the function going? So if you look at the function, where is it going? It's going down to what infinity? Negative infinity, so it's going down there. And then this means as x is getting bigger, here I am, I'm blue, and I'm getting bigger, 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 bigger. In purple, where is the function going? Down again to negative infinity. Okay, so that's what the end behavior means. It's really easy when you're talking about quadratics because they're going to be the same. They're either both positive, they're both negative because you're either going up or you're going down. But next chapter and the chapter after that, it's going to be a little different. You're going to actually have to understand what it means to be going towards negative and then where your function's going. Okay, so I just want to draw that one out for that one. We won't do that again for the others. Okay, intercept form. This is really nice. It gives it to you in the name. Intercept forms means that we can do our x-intercept, or we can find our x-intercepts. So standard was y, intercept form is your x. Okay, just like when we were talking about vertex, if it's in parentheses, it's always going to be the opposite sign. Okay, so just for the sake of notes, I'm going to show you guys, it's going to be P comma 0 and Q comma 0. Just based off of our form here. Now, if this was a positive P, it'd be negative P. Okay, it's always the opposite. Then you can obviously find your concavity. You can always find it. And your end behavior, always. So again, in red, the only thing that's unique to this function is knowing where your x-intercepts are. And once we get past this chart, we will fly. That's kind of just getting used to it. Okay, are we concave up or down? Up. Okay, here's why. Right here, it's positive. There's no negative out in front. There's no negative next to the equal sign, so it's going to be concave up. Okay, we have two x-intercepts. I'll help you out with the first one. The first one is coming from here, so it's going to be 2, 0. Remember, x-intercepts the y is 0. Okay, now what's the other one then? 4, 0. Thank you. That was supposed to be an arrow. What'd you say? You are smart. Okay, so here's the trick with end behavior. If you're concave up, you're going to positive infinity. If you're concave down, you're going to negative infinity. You don't have to draw it out every single time. So if we are concave up in the situation, where are our ends going? Up to positive infinity. Again, you could just sketch a graph for yourself if you want. Up to you. If you get stuck on the exam, plug this in the graphing calculator and you can figure it out yourself. But I would recommend trying not to do that. Questions? Okay, this one should be the easiest one of the bunch because we've been doing it for like 2 weeks now. Anything with vertex, so vertex form. Okay, so we can obviously find our vertex. And if you remember, it's h comma k. In the formula, it's hk. And again, in parentheses, it's always the opposite sign of what it is. So it looks like it's negative, but it's really a positive for our x value. Okay, we can also find, again, your concavity. And you can find your end behavior. There's always 3 things you can find, but each one has a unique one. The vertex form is vertex. Intercept form is your x-intercept. And standard form is your y-intercept. All right, so here we go. Are we concave up or concave down? Down. Again, coming from that negative out in front. What is our vertex? You've been practicing this. Good. Negative 3 comma negative 1. Good. Yes. And it would be negative infinity, yes, for our end behaviors because we are concave down. Very good. Okay, so again, getting used to these forms.
Is there any problems that's going to be like one's negative infinity and one's positive?
Next chapter. Yeah. Yeah, so that's a good question. I talked about that a little bit earlier today. There will be a situation in the future, not this chapter, where these won't be the same. And we'll approach that when we approach it, but for now, just knowing where the arrows go, the ends of your graph, is going to help you out here. Okay, so for parabolas, they'll always be the same. All right, so what form are we in for example 1a here? Vertex. So obviously, we can find our vertex, and let's go ahead and do that. What is our vertex here?
4, 3.
Good, 4, 3. All right, your voice is off today.
What?
Like, for the rest of the period.
Yeah, so stop talking about that.
No, I love that you know what you're doing, but now I need to know that everyone else knows what they're doing. Okay, so you got a gold star today, so good job. Okay, is it concave up or concave down? Up, thank you. So concave up. So those are the 2 things I'd want you to write. And because it's concave up, what's our end behavior?
Positive.
Very good. Lots of gold stars today. Flip when you're ready so I know you can move on.
Can I actually get a gold star?
I can give you a colored star. It won't be gold. I can give you like a blue or a green.
Don't be satisfied unless it's gold.
Okay, I will have to see if I can somehow get you a gold star. All right. What form are we in for B? Yes, there are intercept form. Yes, x-intercepts is what we can find. Intercept form, which means we can find the x-intercepts. Okay, there's two of them. There's one here in purple and there's one here in blue. What about the purple one? What's our x-intercept? Yep, 3, 0. Good, and negative 5, 0. It's always the opposite sign of what's in the parentheses. Okay, and are we concave up or down?
Down.
Ooh,
Up.
up. Okay, because here in yellow, it's a positive in front. Okay, so we're up. And because we're up, we're going to be going towards positive infinity. Yep. Very good. Almost there. Almost there already. Pretty quick day. Questions, comments, concerns? Okay, what form are we in for C? Very good, standard. Now, standard form is usually the one where people get confused on because they don't remember what is available. But what is available is our y-intercept, and that could always be found at the number. What is our y-intercept? Not 3. It's 0 something.
5.
Just 5?
Negative 5.
-5. Good. So this all the way out here is going to tell you what your y-intercept is. It's just the number, the one with just the number. Now here, let me kind of challenge you here. If I were to like get my whiteout pen and do this, what would be my y-intercept now? Yeah, 0, 0. Okay, good. I'm glad that you understand that. So again, the y-intercept is the number. If there is no number there, it's 0, 0. Okay. Are we concave up or down? Down. Concave down, which means we're going both to negative infinity. Good. And that's how we know concave down is at negative out in front. All right, so now let's use your brain and apply everything that we just learned for some logic here and see if we can do like a process of elimination. So the question in the next one says, determine the form of each quadratic. So let's do that first. F of x right here, is that going to, what one is that? There's 3 of them. Standard, vertex, and intercept. Yep, your intercept. You can write it off to the side, that's fine. This one is also intercept. I'm just maybe going to put like an I. Let's not waste time. Okay? What about the next one? What about H? What about J? Intercept. What about K? Good. Standard. What about M? Very good. Okay, so being able to just recognize it quickly like that is going to help you out in the long run. Okay. So now again, the goal is going to see what can this, which one of these functions, or there's more than one, could be this graph. We don't have any numbers or anything going on here, but we can make some assumptions. So there's a couple of things when I look at this graph. Let's talk about it. Is it concave up or down? Down. So this is concave, concave, down. Oh my God, I cannot write today. It's supposed to be an N. Concave down. Okay, so right away, which one could be canceled out because it's not concave down?
2.
The J, very good. Okay, so that one's gone. We just crossed it out. That can't be because it's supposed to be concave down, and this one says concave up. Okay, cool. Now let's look at our x-intercepts. There's one here and one here. These are my x-intercepts. Are they going to be positive or negative x-intercepts? Negative. So negative. There's going to be more than one. Okay, so let's take a look really quick. I have 1, 2, 3 of them that are in intercept form, so let's take a look. Remember, it's always the opposite of what's in the parentheses. So would these intercepts both be negative?
Yes. No.
Oh, yeah.
They will be because, remember, it's always the opposite of what's inside. So it's a -1 and a -4, which could be. So this one's good to go. I'm going to circle it.
I think that's it.
No, there's more. Again, you can kind of check it off. Concave down, check. Negative x-intercepts, check. We're good to go. Okay, the next one. The x-intercepts in G, are they positive or negative? Positive, so they're gone. Goodbye. Get out of there. Okay, so we just eliminated those. Now let's go to vertex.
Positive and
Ooh. Thank you. Okay, so you're kind of right with the positive and the negative. The x value is going to be what? Positive or negative?
Positive on both sides.
no, it's gonna be positive.
So let's think about this. If I go left, is that positive or negative?
Negative.
Negative. And if I go up,
That's positive.
positive. So I have negative,
2.
positive.
Oh.
So, just kind of, no, we're just talking about the graph right now. We're just like visualizing. So I know that when I do vertex, it better be a negative and a positive. Okay? So, what about this one? What's the vertex of this h of x? What is the actual vertex? Yeah, 3.
0.
You're right with the 2, but it's just whatever it is. Only when you're in parentheses does it change sign. So the negative 3 became positive. This stayed the same. And that's not what we can have, right? So that one's gone. Okay, remember we wanted a negative and then a positive. We have a positive, positive. That's not working. Again, just kind of using that brain. You won't be asked one this complicated on the test, but it's just like I might give you one. Like here's one graph, find the one that matches it. Okay, let's go to another vertex. What is the vertex of m of x down here? What is the vertex of this guy? Good, negative 3, 2. Is that what we wanted? Do we want a negative and then a positive? Yeah, we did. So boom, that's another one.
Is that the only one?
There's one left.
So it'd be the one.
Well, we don't know. I'm saying there's one more left we have to check. This is standard form. So what do we know about standard form? What can we find? The y-intercept, what is it?
Negative
0,
zero,
-6. Let's see if that's possible. If I were to extend this and extend this, could this be a -6? Maybe.
I don't know, that looks like 10 or something.
I mean, it does, but like, what if I was going by 0.5? Or like 0.2 or 0.1? But like, it's negative, right? Okay, so then we're good to go. Question. Again, maybe write this out for yourself. The y-intercept had to be negative, just so that you know of why that is. Okay, you have a very, very long time to work on your homework, like 28 minutes. So before I do that, I want to show you what I made. So for the whole chapter on haiku, I'm going to start doing this. I posted this already. This is the whole entire chapter. You can see everything we're doing. Okay, here comes your test. This is what we're doing today. But what's nice about it is that the notes are here, the homework's here.
That's amazing.
Okay, so you click it, boom, there they are for you. Okay, they're the blank ones. The keys will still be posted for you to see and to check your answers. Then you know what's coming up as well. There are a lot of people, maybe not in this period so much, but in other classes that are absent a lot, and I felt like this would be useful. Okay, what else did I have to say? It's wrong, so cross off 8. Because there's actually 2 right answers for number 8, but... So cross off 8. I also want you to do this. So for number 8, you can skip, so skip 8. For number 11, please write this out. And you're probably going to be mad that I put another one of these on there, but it's only for you to practice. Write out your vertex formula because I will give you this on the test on Thursday. Try very hard on number 11 to not use notes to see how to do it. See if you can do it now without the use of notes. Give it another round. I'm putting that one on there again because that's the one where we see the most incorrect answers. Tomorrow we review together. We'll play like a review game of some sort because this class I think can handle it. It'll be fun. And then we'll have a test on Thursday. Okay? Part 1, you guys should be really good. Your skills checks were amazing, so awesome. The reason if some of you think they were going really slow, I understand that. But we had to really go slow on these concepts because the next couple of chapters are going to be a lot harder, but like they're the same concept. So for you to understand the easy concept and grasp what it means, it'll help you in the long run. See the keys up there for you to check your answers? Number 10, I would like star it. That one's a good one. I'm saying that that's a good multiplication.